right? So we're not a line. So we have a curve in it. We're not part of a line. That's straight. Kind of looking at that. So we've got two groups, right? Linear is what we talked about yesterday, right? Those are those straight line graphs. So start here, right? I go straight up. You go straight across. I kind of have my dots that are going straight up. Linear is all we've looked at up until this point in the year, right? So nonlinear, right, are these ones. So if I look, right, I've got a curve here. I've got a curve here. The question is, though, right, this one appears to me, besides the fact that I have a hard time drawing straight, right, it's fairly straight lines. So anybody think about why that one is not linear? Logan?
It's not straight. The line's not straight across.
Okay, so what Logan just said is the line's not straight across, right? Because what happens right here? Changes direction, right? So because it's not going, like straight down that way or straight down that way, right? That's nonlinear. So that's how we can tell, kind of in a graph if I don't have a straight line. So what about from a table? All right. So when I look at the table, I want to look at the y values, right? And then I want to see what the difference is, right? So from 12 to how do I get from 12 to 13?
Add 1.
Add 1. 13 to 14? 1. So if the difference between the y's is the same every time, right? I have a linear function. Okay, so that's really what we looked at yesterday. All right, and so now I want to look at and say, let's just do a quick review and say, how could I write that equation, right? So I know I have y equals, what's my slope? 1, right? That was my change. I have that 1x. Does anyone remember how I could figure out what I need to add or subtract here?
How'd you get 1?
Because that was my slope.
How?
Because it's my change in y's. So what happens if I plug in 0 for x? What's 1 times 0?
0.
0. How would I get to 12? To add 12. Alright, so that's how I could write that equation. Okay, so it's kind of a review from yesterday if you weren't here. We can talk more about that later on. So next one. Okay, and say, how do I get from 10 to 12? Plus 2. 12 to 15? Plus 3. What do you notice?
It's going up by 1 every time.
So it's not the same. So it's going up by 1. It's not the same difference, right?
Like, it'd be like 2, and then next one would be 3, and 4, and 5.
Yeah, so if I look right, I've got 2, I've got 3, 4, 5. So there's obviously a pattern here, right? But these numbers are not the same, right? So when you don't have a common constant difference, right, it's nonlinear. Okay? So that's kind of how we see that. So we're going to flip over and we're going to look at the other side and talk about how do we actually write those equations.
I'm going to Florida in a month.
Cool. So if I look at this first one, right? First thing I want you to do is check the difference here, right? So negative 2 to 1 is what?
Minus
3?
Wait, no.
Plus 3, right? So I go negative 2 to 1. 1 to 4.
Plus 3.
4 to 7. 7 to 10. 3. So what kind of function do I have? Linear. Right? So I can say I have a linear function. And now I've got to write the equation. Right? So I got to think y equals, what's my slope here? 3. What goes with that 3? X. Now I've got to figure out what I'm going to add or subtract here. Negative 2. Right? I'm going to subtract 2. So what happens if I plug in 0? 3 times 0 is 0. And I know at 0, I want to be negative 2. So how do I go from 0 to negative 2?
Negative 2.
Subtract 2. All right, so there's my equation. All right, so now if I look at this next one, right? 0 to negative 1.
Negative 1.
Negative 1 to negative 4.
Negative 3.
Negative 4 to negative 9.
-5.
And negative 9 to negative 16?
And then, would that be like 7?
Yeah. Okay, so what kind of function do I have? Nonlinear. So now what I want you to think about is, what is a nonlinear function? What is that going to look like? All right. So kind of over here, I'm going to have x to some sort of exponent. Or I'm going to have a number 3 to the x, right? Or like 5 to the x. Those are the kind of functions that are going to be nonlinear that we're going to look at, right? So if I look up here, right, what's the exponent with that x? Like x to what power? Everybody know?
The first?
First power, right? Linear equations are x to the first power, right? You see like x squared, that's the second power.
What is that?
5 to the x power. So now the question is going to become, though, how do I figure out what the exponent is? So here's, I'm going to show you another way we can look at this. Let's look and take the difference here between, what's 1 minus negative 3?
-2.
2, right? 1 minus negative 3 is 2?
2?
Yep. Negative 3 minus negative 5? Negative 3 minus negative 5?
I don't know.
2? Right?
I don't know.
So negative 1 minus negative 3, right? Negative 3 minus negative 5. Negative 5 minus negative 7.
2.
Bring it back together, guys. 2. So what do you notice?
It's all 2.
It's all 2, right? So that helps us because how many times did I take the difference of things?
3 times?
No.
Once?
Twice, right? This is the first difference. This is the second difference. You guys need to focus. I'm almost done. Second difference, I got all the same. So when you go to write this equation, right, because you took the difference twice, your exponent's going to be that same thing, right? So I did it twice, so my exponent's 2. Okay. So now I need to look and say, is that good, right? Do I need to do anything else? So if I plug in 1, right, what's 1 squared? 1. So how would I get that to be a negative 1, though? Multiply by negative 1. Right, so I have a negative x squared. Okay, so a lot of times when you're nonlinear, you have to look at, do I need to multiply or do I need to add? All right.